Imagine you're waiting at a traffic light. You want to know if you can cross the street safely. The rule is you can cross if the light is green and there are no cars coming. Now if the light is red, you don't even need to check if cars are coming. You already know you cannot cross. You stop right there. About the signal of the traffic light, there only exist two cases. Either it's green or red. If the light is not green, then it must be red. Thus, if we use Boolean to represent the status of the traffic light, light is green is true when the light is green, it is false when it's not green. It's red. This is exactly how short-circuit evaluation works in Python code. When Python sees an AND condition, it checks the first part. If the first part is false, like the red light, it stops checking because the whole condition can't be true. It's like stopping at the red light without looking for cars. This saves time and makes the program faster because it doesn't waste effort checking things it doesn't need to. Here's an example in code. Since light is green is false, Python doesn't check cars coming at all. It knows the whole condition is false and tells you to wait. This is about a concept from Boolean algebra. This is a representation of A and B. In the example above, light is green is A, while not car coming is B. Recall there's a no law when using the AND gate. If we have already known one of the inputs in the AND gate is a 0 or a false, we can directly deduce the output of the AND gate is 0, disregarding the state of the other or the rest of the inputs in the AND gate. Yup, the B is ignored. So go back to our traffic light context. The Boolean light is green is known to be 0 or false, meaning that the light is not in green but in red. We can directly ignore the state of the remaining input of the AND clause, which is the state of the Boolean not car coming, and directly run the blocks of code under else clause, which is to print
wait.
So just like you stop at a red light without looking for cars, Python stops checking conditions as soon as it knows the answer. That's a short-circuit evaluation. Walrus Operators. The Walrus Operator is a special feature introduced in Python 3.8 that lets you assign a value to a variable inside an expression, such as in an if statement or a loop condition. This means you can both compute something and save it to a variable at the same time, making your code shorter, cleaner, and often easier to read.
Oh yeah.
Imagine you're building a simple Amazon shopping cart program where users add items one by one. The program should keep asking for items until the user types done. Then it shows all the items in the cart. Here's the code. The input can either be the name of product or done. If the input is the name of the product, then it will be added to the cart list, just like you putting groceries in a cart. If the input is the string done, then it will stop asking the user to input and print the things inside the cart list. Notice you have to write the input line twice, once before the loop and once inside it. With the Walrus operator, you can simplify this. The Walrus operator assigns the user's input to item and immediately checks if it's not done. If it's not done, the item is added to the cart. This repeats until the user types done. Membership operators. Python provides two membership operators that let you check if a value exists inside a collection. In returns true if the value is found in the sequence, just like A is in the list. Thus, the result of A in list is true. Not in returns true if the value is not found in the sequence, just like A is in the list. Thus, the result of A not in list is false. Both operators return a Boolean, true or false, making them very useful in conditions and if statements. Let's say you have a sentence, I go to school by bus. So there are some cases here, because bus is in the sentence, so it will output true. Because church is not in the sentence, so church in sentence will be false. Lastly, because train is not in the sentence, if we print train not in the sentence, we'll have an output of true. Using any and all with collections. Any and all functions help you check conditions across multiple elements in collections like lists, tuples, sets, or dictionaries. The any function returns true if at least one element in the iterable is true. If none of the elements are true, it returns false. If the iterable is empty, any returns false. Now let's say you want to check if a Nike shirt has a 10% discount. We first have a dictionary named Nike shirts discount, then follow with an if statement. In the if statement, each of the values of the key value pairs will be stored into the discount and compare if the discount is greater than or equal to 10 one by one. Since shirt C has a 15% discount, any returns true, so you know that's good deal available. The OR function returns true only if every item in the group meets the condition and returns false if any item does not meet the condition. Imagine you want to check if all students submitted their assignments in the following code. There's a dictionary named assignment submitted, which stores values of each of the students has handed in or not this assignment in the key value pairs. Then if followed with an if statement, it will check in the assignment submitted dictionary. If all of the values are true, then it will print a message about all students have submitted the assignment. Since student 4 has submitted, all returns false, so you know some assignments are missing. If statements with context managers. A context manager is a way to set up a temporary environment for a code to run in, and then clean up afterward automatically. The most common way to use a context manager is with the with statement. Suppose you want to check if a file named assignment.txt exists and contains any content. You can try to open the file safely with a context manager and then use an if statement to check its contents. First, os.path.exist checks if the file assignments.txt exists on your computer. If it exists, the with statement opens the file safely. Inside the context manager block, an if statement checks if the file has any content. After the block, the file is automatically closed even if an error happens. If the file doesn't exist, the program informs you right away. Guard clauses and early returns. A guard clause is a specific type of early returns placed at the beginning of a function to prevent the main logic from running if key conditions aren't satisfied. Early returns means exiting a function or methods as soon as certain condition is met, usually to handle edge cases, invalid inputs, or special conditions. Let's see using guard clauses and early returns in a real program. Let's say you want to check if file upload by checking if the file is a Word document and is under 50 megabytes. You type, the function exits early if no file is provided. It checks if the file extension is docx and exists if not. It verifies the file size is within the 50 megabyte limit and exists if exceeded. Only if all conditions pass does it proceed with the upload. Debugging with else clause. An else clause in debugging is a tool when used with conditional statements like if to handle cases where the primary condition isn't met. It is similar to guard clause we've mentioned about. What it helps further is that you log or inspect what is happening when your code doesn't follow the expected path, making it easier to diagnose issues. Let's say you're writing a function to process a user's age for a registration system. You want to ensure the age is valid, log issues for debugging, and proceed only if everything checks out. Here's an example. The function first checks if the input is an integer and logs a debug message if it's not, then exits. It then verifies if the age is at least 18, logging a debug message and exiting if the user is too young. Then it checks if the age is realistic, logging a debug message and exiting if it's not. The else clause logs a confirmation that the age is valid before proceeding with registration. Now you've learned how to use advanced Python if statement operators. Watch this video next to learn about Python JSON. See you there.